Hello everyone. In our last Bevy Basics tutorial, we started off with a simple space shooter game where we implemented periodic spawning of laser beams from a player ship and also some basic collision detection to damage the enemy ship when hit by a laser beam. Today we'll continue from where we left off and implement some basic 2D character movement and shooting using the mouse and keyboard inputs. So let's begin. First up, we define two empty marker components, namely the player and the laser component, in order for us to be able to query the player and the laser entities, as we shall see in a moment. Then in our player bundle, we add the player component. Similarly, in our laser bundle, we add the laser component. Also, we change the signature of the function to take an additional transform input. This transform indicates the origin of the laser beam, since our player will now be moving around. We assign the position of the laser sprite to the translation of the input transform and the heading angle of the laser to point to the heading angle of the transform, which is given by the X direction or the right direction in 2D. Then we handle the player orientation according to the position of our mouse cursor. We query for the camera and its transform and the mouse position in our primary window. Then we use the viewport to world 2D function on our camera to transform the cursor position to a 2D position in our world. Then we compute the vector from the player's current position to the mouse cursor position, compute the angle in XY plane, and assign the angle as the player's Z rotation. That's about it for our handle player orientation system. In the player shooting system, we fix the inputs to the laser function by taking in the player transform as an additional input and passing the transform to the laser function that outputs the laser entity. Then in our main function, we add the new handle player orientation system to our update schedule. And now if we run our app, we will see that our player ship orients itself towards the mouse cursor, and the lasers are shot in the same direction. Now we'll try to make it a bit more interesting and move our player freely around the screen. First, we need to shift from a 1D movement to a 2D movement. To achieve that, we change our speed component into a velocity component. We also define a couple of constants and an acceleration component. Since both of these components are 2D vectors, they both wrap a vec2 value. Then we define a handle acceleration system where we query for all entities with an acceleration and a velocity component. First, we reduce the player velocity by applying a drag force in the direction opposite to the velocity. The drag force is used to make sure that we have a natural cap on our maximum velocity. In actual space, in complete vacuum, there is no air drag, of course, so we can assume that our drag force here is due to some thrusters that are installed in our player ship to provide a constant drag in the opposite direction of motion. Once we have reduced our velocity, we now increase it by applying an instantaneous acceleration for the given time delta. We make sure that this acceleration is only applied once by setting the acceleration to 0 afterwards. Now in our player entity bundle, we add the velocity and acceleration components with initial 0 values. Then we have the system for handling key presses to move our player around the screen. We take as input the button input resource and check for WASD key presses. Accordingly, we set an acceleration vector to store a +1 or -1 value for any up-down movement in the Y component and any left-right movement in the X component. Since both components can have a non-zero value at once, we need to normalize our final acceleration vector to make sure that the magnitude of acceleration remains the same in all directions. Finally, we multiply our vector by a constant that indicates the magnitude of our constant instantaneous acceleration. For our move entity system, we just need to do a small change. Previously, we would move in the forward direction of an entity only, as the speed was a scalar. In the new version, we simply replace speed with velocity and translate the position of the entity along the direction of the velocity. In our laser bundle function, we also replace speed by velocity and use the forward or local x direction of our transform as the direction of the laser's velocity. Now in our main function, we add the two new systems, the handle acceleration system and the handle player movement system, to the update schedule. And now when we run our app, we can move our ship around the screen using the WASD keys, and of course turn around using the mouse. The lasers fire beams from the position of the ship at regular intervals as before. To implement player shooting using the mouse buttons, we just need to make a simple change. We remove the time and shooting timer resources entirely and replace them with a button input resource of type mouse button. We spawn the lasers when the left mouse button is clicked and released. Usually in FPS games, holding down the left mouse button would fire continuously, but to implement this, we will need to use another timer to make sure we're not firing at a much higher rate than a constant fire rate. If you guys would like to see how that's done, leave a comment below and I'll explain this technique in a future video. We also add another system to despawn our lasers when they travel beyond a certain limit from the player's position. We do that by querying for all laser entities, and for each of them, we check whether their position is farther away from the player's position than a constant limit. In case that's true, we immediately despawn the laser entity. And finally, in our main function, we add the despawn laser system to the update schedule. And now if we run our app again, we can fire lasers by clicking on the left mouse button. So that was it for this video. If you'd like this series to continue, please let me know in the comments below. And until next time, thanks for watching.